Hi folks, welcome to another episode of NYC CNC. Let's try polishing up this O1 die. I showed you how I used it in the previous episode. It worked fine, but it's not hardened. And I really want this to be hardened to prove out that it works, if you will. I also want to polish it. The inside isn't bad at all, but you can see it's not a mirror. The rim around the lip isn't bad, but it's just not as good as I want it to be. So I coincidentally was digging through some old stuff and I found this kit I had bought probably 10 years ago, and it's called a Nico Nostalgia Enterprise from Brownells, and it's a 22 caliber long rifle barrel lapping kit, or pressure fire lapping. I used it at one point to lap in a target barrel, again, probably 10 years ago, and never used it again and forgot I had it. And sure enough, what I'm excited about is it is a series of 4 grades of lapping compounds: 220, 400, 800, and 1200. And I'm actually really excited to have that series of progressions across one grade or one manufacturer of compounds. What you really want to buy to do this, as I understand it, is the diamond stuff, but it is expensive, and I'm not at that point yet. We were lapping these in on the Emco lathe, but that was, for me, really more to get it the right size. I didn't view that, and we did go up higher grits toward the end, but I wasn't comfortable that was really polishing it, which is kind of what I want to do. So I was trying to figure out what's the best way to polish the inside diameter. I was talking to a buddy who used to work at one of the big ammo household name ammunition manufacturers, and he was telling me some really interesting things, including some sort of tips on how they made their own dies. And as we were talking, it occurred to me, well, wait a minute here. Let's use different types of brushes and apply the lapping compound onto the brush, and then while it's spinning, just use a Dremel. So we're going to experiment with that. I did a little bit of experimenting offline here on a piece of aluminum, and it worked fine, but I figured let's give it a real shot here on camera. Now the thing is, I want this to be rotating while I'm doing it, because I'm not going to want to have to buy brushes or felt bobs that are the correct diameter. In other words, that have a consistently round fit in each size hole. So what you want to do is be able to hold the Dremel and the bit at the bottom, say, as it's rotating around. Now I don't want to do this in my lathe. It's not as comfortable. The lighting in my situation is not as good. But most importantly, I don't really want lapping compound getting thrown all over my lathe. So we're going to try hooking up a gear motor here, and that'll rotate our part. So we're going to first make a holder that'll attach to this. This is just a really old Merkel Korf gear motor left over from another project. And then that'll let us sit here comfortably at our bench and work and test our progress and pull it in and out quickly and take looks. So first thing we're going to do is make a adapter for this. But before we jump into that, I thought I would just show a project I just finished up for a customer. This is the top side, I think, of a home injection mold die, and you can see here in the CAD model, it looks like there's a very pronounced shoulder in this rim running around the part. But what you don't realize when you're looking at the CAD model is that rim is actually only about 18 thousandths wide, or a little over 4 sheets of paper. So sure enough, as you're looking at the part, it's darned hard to see it. Now I don't have any concerns about the spec or the tolerances, because I know my Tormach and I trust it, and I know the setup I was doing and the cuts and all that. But nevertheless, as I'm trying to bone up my machine skills and prove out parts that are working right, and especially just after having read that book, Metalworking Sink or Swim, that I just did the review on. To me, what's always been impressive about good machinists, is their ability to think creatively. And that's kind of what's interesting to me. Machining a lot of times isn't as high stakes to me as, say, a welder or sort of like a surgeon, where it's what you're doing in the heat of the moment that can totally make or break the whole thing. You know, obviously surgery on somebody or as you're actually running a weld through. A lot of times to me, machining is more about the setup and thinking ahead and stacking the deck in your favor. Now, sure, you can put a lot of work into a part and take progressive cuts on it that can be a real big bummer if you blow it, but you usually don't have to do that on the fly. You've got time to think about it and so forth. Anyways, so I want to check the tolerance of this part, and calipers are not an accurate way to do that. Way too small for snap gauges, and it occurred to me, a totally obvious point, but gauge blocks. So it's quite simple. We know the two dimensions. The wider top dimension is 138 thou, and the inside groove at the bottom is 120 thou. So all we are going to do is grab the 138 gauge block, make sure it's clean, and just use these kind of like go, no go gauges. So this should fit in. Yep. Now you do get some play in it. We'll see if that's because it's such a shallow piece. That might just be because of it. See if the 139 fits in. Okay, so the 139 fits in, and that is the better tolerance. So the truth is I'm probably a thou over. That's actually within the spec of this part, but it would be good to know if I was trying to hold a tighter tolerance, and the 140 does not fit in. It goes in just to the radius of the chamfer of the gauge block. Now the lower one is 120. Make sure it's clean. Okay, that fits in, and that's actually a great fit. So let's see if the 121 fits. Nope. Okay, so the 120 tolerance is actually tighter than the top one. I did use different tool bits, so there actually may be a little bit of run out in the tool bit I used for the top cut. Again, it's okay here, but you'd want to check that and take some test cuts and measurements if you were really trying to get into the thou and under tolerances. So let's tackle making a little bushing here for this motor. It's a 1/4 inch shaft. I've got a set screw, or it's a D shaft, so I'm going to put a set screw on this side, and all of our dies are 1 1/8, so we don't have any real constraints here. So what I'll do is I'll just bore out a piece here to hold the die, and then we'll have a set screw here to hold the 1/4 inch hole to hold the shaft. So let's, excuse me. So let's hop over to the lathe. Actually, so let's make a quick drawing. I like using cardstock sometimes for drawings. It's just a little more rigid. So, and you're gonna have to forgive my not the best drawer in the world. So we're gonna have a 1/4 inch hole. And how deep do we want that? Oops. Yep. So we'll do that to about a little over 1/2 inch, and then we're gonna want to come in. We know that's 1 1/8. I don't know why I'm writing in fractions. I should be writing in decimals, if that's okay. And the depth of that is, we can actually have our part sticking out a little bit. So we can do that to 750. So we don't really need this gap in here. So the overall dimension of our part can be, call it 1.5 inches, which will give us, about 2 inches in the middle there. And then we will do a set screw, and we want that sort of centered along the shaft, so that can be at 1/4 inch back. For the set screw, and we'll do a set screw, and that can be halfway back, so 0.375 set screw. And we want at least, you know, at least probably 3/16 or so of meat around the die for that set screw. So, oops. Yep, so that's perfect. So we'll use 1.5 inch stock. Oops. Perfect. So there's our little sketch just to run over the lathe with. I had a 1.5 inch piece laying in the scrap bin. It has a thread in it, but it's smaller than 1/4 inch, so we should be okay. It's a little bit longer than we want, but that'll be fine. So let's go ahead and get this made up. You can see our holes off center. Again, we're only turning the bushing at low RPMs in our motor, so I'm not going to worry about it. Okay, we should be good on that side. Okay. So we want this out to 1 1/8. So we're going to start by drilling it 1/2 inch. Now this could be a little wonky because our hole's off center. So we'll see. We're going to turn it slow. See how this goes. Okay, that's fine. New can of Aluminitap. It's got a cinnamon smell to it. I don't remember that. Okay, so I'm at 1/2 inch on my tailstock. We want to go in to, we want to go 3/4 deep, so I'll go into 1.25 or so. Okay. Okay, now we'll drill out 15/16. I do have a 1 inch drill, but I don't want to take that much in case we're off. So I'm going to slow this down. And we'll bore out the final amount. I don't want to run out too far here. Watching one of Keith Fenner's recent videos, you can see that my drill bit, and Keith talks about this, I'm cutting more on the left flute than on the right flute, which means one side's got a little sharper, a little bit longer. No big deal for here, but if you really were concerned, you could dress that up. See, I didn't pay attention to where I'm in. So I'm a little deeper than 1/2 inch to start, so we'll go to about 1.5 inches on the tailstock. They're nice chips. Okay, perfect. Let's see, where are we at? Go grab a snap gauge. Okay, 93.75, so we want to be at 1 1/8, 1.125, 0.9375 minus 2 divided by, so we've got to go 93 thousandths once we touch off with our boring bar. So okay, zoom in a little closer here for you. Okay. We set our 0, and we'll come 40 and start there. I didn't set a depth. Let's set a depth first here on our travel stop. .015, so 1.125, 1.015 minus 2 divided by 55 thousandths. I don't trust that measurement though because of how rough that surface finish is. You can see there, so let's come out, 40, 10, 20, 30, 40, and get hopefully a nicer surface finish here, and we'll try again. Okay, 14 thou. Okay. Right on the money. Perfect. Nice fit, and we're right at the depth we want. Now I have I don't know what you want to call it, a habit or proclivity to always wanting to have an OD that's concentric. I don't know, it's just easier sometimes to come in on the part if you need to do a follow-up op. Now I've got to be careful because these jaws stick out. so I can't go too, I got plenty of room here. We're just going to turn a little bit of this outside surface here. Okay. Let's break our edge. Turn the lathe backwards. Sanity check. Perfect. So okay, so now all we need to do is actually, you know what we're gonna do? There's no need to tap such a deep hole, so let's just go ahead and turn down. Trying to think here. Nah, we'll just tap that. It's easier. I'd rather leave the meat of the material there if we need it for some other reason. So we'll let's go ahead and tap a set screw holder to hold our die in, and then to hold against our D shaft. Okay, let's go ahead and drill and tap. We are just going to eyeball the center here. If that upsets you, I don't know what to tell you. It'll be fine. We are going to grab our drawing though to make sure we go in the correct depth. That I do care about. Okay. I care about, you know, broadly speaking. Okay, so we're going to do both of these actually 1/4 I've got enough meat on the thin side that I'm okay using a quarter inch set screw. So spot them up first. Actually, I am going to just go ahead and finish this one before we move our table. Number 7. Perfect. We are right on center. Now, I don't want to tap that whole length, so let's go ahead and drill out part of it to 1/4 inch clearance. Okay, so I'm at, I'll just kind of eyeball my drill depth here. Okay, perfect. Okay, we're straight, so I'm going to do the rest of it by hand here. We're through. Okay. Let's flip our part around. We'll be able to see our center line easier. Let's see here. Yeah, so I want this one about 3/4 inch back. Sorry, 3/8, which puts me right about there, ballpark. Okay, we're through. Okay, let's go back to the bench and see how we did. Okay, let's do a quick wipe of our part, see how our motor shaft fit is. Well, that's great. That's actually better than I thought it might be. Okay, so let's actually, we're going to use a set screw on our die side, and we're going to use a socket head on our other side. So let's see how that fits. Probably have a little burr. There we go. Perfect, that's not going to go anywhere. And let's grab a socket. Let's grab a, okay, perfect. Okay. I should really throw this out because it's busted and I've got 1,000 good ones. Okay, that's not going anywhere. Perfect. Now let's get some power on this and see how she turns.